Hi guys, so here we are with our episode 3 of the intelligence layer. This is one of the interesting topics for me and also kind of a foundational thing for, in fact, all SCM professionals, I would say. So let me start this episode with an uncomfortable question which will make your life comfortable. Is your organization using one forecasting model for every product in your portfolio? A hero SKU that has been selling for 5 years, a new launch with 3 months of history, a slow moving SKU, a seasonal product that spikes once a year. All of them are getting same model, same treatment, same parameters and same logic. If the answer is yes, that is not a forecasting methodology. That is a coin toss with a spreadsheet attached. I will tell you one exercise with no new software, no new data, no new hire, which reduces forecast error up to 40%. The 40% I'm talking about is an actual worked around figure in the real world and not a theoretical figure. This episode shows you exactly how. Make a note that the wrong model is not a small error. It is a systematic error which will take you to same direction every planning cycle and which will keep on compounding. So before you pick any forecasting model, quantitative or qualitative, one question must be answered first. Do you have reliable historical demand data for this product? If the answer is no, no comparable history is available, no prior sales, and it's genuinely new territory, then a statistical model has nothing to work with. You need qualitative methods, structured human judgment from people who know the market and the customer. If the answer is yes, the product has a track record, the data exists, and is reasonably clean, then a statistical model can find patterns, weigh recency, and account for trend and seasonality. This question sounds of obvious question, but it is not. Most organizations go straight to the quantitative model regardless of whether the data actually justifies it. A new drug launch with 3 months of history gets the same exponential smoothing model as a generic that has been selling for 10 years. That single omission is where the systematic error begins before a single parameter is set. Most organizations skip this question entirely. They go straight to the model. That is where the systematic error begins. Four qualitative methods. The principle behind all of them is the same. When reliable data does not exist, structured human judgment is the best tool available. The word structured is doing all the work in that sentence. So, the first is expert opinion, which kind of sounds rigorous. In here, a group of experienced managers independently estimate demand, and the results are kind of aggregated. In practice, most organizations skip the independence. The most senior person speaks first, the room adjusts to that number, and the exercise becomes one person's view with everyone else's silence attached to it. So, the second method, Delphi, fixes exactly that problem because it comes with anonymous submissions, results are shared and revised independently, no hierarchy. It kind of removes the seniority bias from expert opinion. But the problem, the trade off is time. Delphi works for long range strategic forecasts, not monthly operational planning. Salesforce Composite is the most widely used qualitative method in Indian FMCG and pharma. Every regional sales manager submits a bottom up number, it rolls up to a national forecast, and it systematically over forecast every single month. I'll tell you the reason why, and I think you know the reason why, which we discussed in kind of episode 2. Because every sales manager builds in a buffer for their target. This time it is originating in the field rather than S&OP. So the fourth is market survey and analogous products. This is kind of useful for genuinely new launches, but you have to take caution that customer surveys measure stated intent, not actual purchase behavior. Use the output as a range to bracket the forecast, not as a precise number to anchor on it. Before we go to the next slide, I would like to repeat one thing. Salesforce Composite is the most used qualitative method in India, but the most systematically biased. You have to know this trap before you rely on it. So, before we go into the seven models, the quantitative models, let us take a look at the landscape. So, this history comes from over 70 years. Forecasting methods have grown up from 6 to 20 and are used across industry. I tried to divide it into three distinct eras. The statistical foundation, where you know, uh, which was through 1950s to 1980. They gave us mathematics of demand history, naive, moving average, exponential, smoothing, halt winters. Six methods built on one principle: find patterns in what demand has done and project them forward. All six are still in active use today. Then came the causal era, uh, which asked a very different question, a sophisticated question, which is not what demand does, but why it moves. Regression, ARIMA, okay, the kind of sophisticated models because the question became more intelligent. If you can find what causes demand to move, the forecast follows from understanding the cause, not from guessing at the number. Then came machine intelligence, profit, random forest, kind of pattern recognition at a scale no human team can replicate. When the data is rich enough to justify this method is used. So 20 plus methods. The good news is that you do not need to master all of them. 7 cover 95% of what you will encounter in real planning operations. The remaining methods exist for specialist problems only. Knowing they exist is enough. Okay, and also knowing when to call someone who uses them, that is what separates a planner from a planning director. Method selection evolved over 70 years, but the thing is that 7 models cover the maximum of it. So let us discuss those 7 quantitative methods. I kind of tried to divide these into 3 simple, tiers. One is tier 1, naive. Naive says next period will equal last period. It sounds too basic to be useful, but on a genuinely stable, low volume, slow moving product with no trend and no seasonality, it outperforms more complex models. The moment demand shows any movement at all, it fails completely. The second is moving average, the last n periods, and the n is everything. A short n makes the model reactive and noisy. A long n makes it stable but blind to change. We decode n in full episode 5. The intermediate tier, exponential smoothing, uh, weights recent data more heavily than the older data because what happened last month is more relevant than what happened 2 years ago. There's a control factor called alpha into it, which controls how much exactly. It is the most widely used statistical method in practice right now. and we will decode what is alpha in episode 6. Halt Winters adds a trend component and a seasonality component on top of exponential smoothing. And we have to use it only when both trend and seasonality are genuinely present in a demand pattern. Not because the model is more sophisticated, but because it is more accurate on that specific demand shape. The advanced tier. Regression is fundamentally different from every other model on this slide. Every other model or method looks at your own historical demand and finds patterns inside it. Regression will ask a completely different question. What external factors is actually causing your demand to move? Temperature, promotional spend, GDP, school calendars, competitor pricing. When you find the causal driver, the factor that genuinely explains why demand moves, the forecast becomes a consequence of understanding that driver, not a guess at the number. Finding that driver is worth more than any model refinement, and it is the insight most planning teams never pursue. Then ARIMA is there, which finds patterns in the gaps between what the model predicted and what actually happened. The forecast residuals, you can call it. It is powerful, kind of powerful on large, clean data sets. On a C SKU with 18 months of sparse history, a simple moving average will outperform it every time. Then machine learning is there, which kind of outperforms everything else on your highest volume ASQs with rich, clean, and abundant data. On sparse CSQ data, it again finds kind of noise and treats it as signal. It produces a forecast that is confident, sophisticated, and wrong. So here it is clean that the best model is the simplest one that accurately describes this product's demand pattern. Always, and fit kind of beats sophistication. So this is part 1 of episode 3. I'll be back with part 2 shortly. I hope this was a great insight from my end. Thank you, guys.